Hello.
Welcome, everybody.
Yeah. Welcome, Tanya, Phil. Welcome to me.
Hi, Danny.
Hi. Thanks for joining us, everyone, whether you're joining live on Facebook, Twitter, or YouTube, or whether you're watching this afterwards. Thank you very much. We're here today getting together to talk about really what's been going on for the last week in planetary science. All anyone's really been talking about. Perseverance, the new rover on Mars. So we'll give you a rundown of what's happened over the last week, less than a week already, or only, and we'll talk about what's to come and what to look forward in terms of this new rover, the fanciest new toy on Mars, which is going to do some really cool stuff. So before I introduce all of us, I'll let you know that when we last saw you, Perseverance, Curiosity, mixing up kids.
We all know which one is your favorite.
Well, actually, I don't have a favorite yet. We could talk about that. But this time it was hurtling towards Mars at roughly about 20,000 kilometers per hour at this point, and getting ready for what had happened last Thursday. So whilst I introduce us, I'll play the video of what was expected, the artist rendition, the fake visuals of what was expected. You can pay attention to that, or at least watch the visuals while I do the introductions. But I'm Danny Bednar. I have a PhD from the Department of Geography at Western University. I'm also an instructor there where I teach space exploration, and I work for the Canadian Space Agency in my day job. Joining me is Tanya Harrison of America.
Of Mars.
Of Mars.
Tanya has worked on all sorts.
Oh, sorry.
Yeah, Tanya has worked on all sorts of planetary science missions, including Mars rovers. She currently works for Planet, a company out of the United States that looks at the Earth, but she's continuously still active in the Martian science community. So thank you. Tanya of Mars, also joining us, Phil Stuke, Professor Emeritus, Dr. Professor Emeritus Phil Stuke.
Yeah, that's me.
Department of Geography at West. Author of many books about Mars, the Atlas of Mars, the Atlas of the Moon, and altogether expert in space exploration and all things Mars and the Moon. So now that the introductions are done, again, we're looking at this, and this was the visual again, the cartoon animation that was put out months ago in preparation for this. And we'll talk about how all of this really happened in real life. And as we learned today, just this afternoon from NASA, we got back a ton of really cool images and videos from this, which is new. We haven't had that on past rovers. So before we get started into that, Phil, Tanya, any first impressions of the week that's been? The press conference today, we'll talk about the videos that came out. But how's your last few days been?
Busy. It's fantastic to see a new place like this. I love seeing new places, and so just getting on the ground safely, that was exciting, and then seeing a new place, I really like to do that, so it was great. One thing that I did learn today was that when they show that video of the sky crane there, the descent stage, with the very visible rocket exhaust coming out of those thrusters, that actually the real thing, that exhaust is invisible, because we got images showing the thing flying away, and absolutely no visible plume at all out of those thrusters. But I guess if you're animating it, that doesn't look good. So when you're doing the animation, you've got to have lots of fires, coming out of the thrusters.
Yeah, I think that the video was not exactly what I expected from seeing the animations, but it was so amazing. Like it's an alien landscape, and you have video of us landing a car on another planet.
Yeah.
Like, it's probably the coolest thing that I've ever seen, like not just from Mars, but maybe like of anything that NASA's put out. I might be biased. I do really like that video of the volcano Tvashtar like erupting from New Horizons. That's pretty cool. But I mean, the fact that we got to see the sky crane fly away from the point of view of the rover and just like yeet off was amazing.
Yeah, it was nearly as good as watching the Apollo astronauts.
I couldn't compare to that. I wasn't there.
That's our monthly. That is a good reason to buy this book. Thank you, Phil, for the link in.
There you got to hold it up again now that I made you big.
Yeah,
every month we have to find a reason to hawk our book.
Buy this book if your kitchen table has a short leg and you need something to put underneath it.
Oh, wow. Phil's just mad because I use his book sometimes to prop up my laptop. They're the perfect size. Yeah, but they're also handy if I need to pull out Mars information.
Oh, well, yeah.
It's like at the ready. That's really what you have it on hand for.
Yeah.
Yes. So, where's Perseverance heading in the grand scheme of things? This visualization has all the American landers. It has the grave mistake of leaving out Mars 3, but I'll let that slide. But this is all of the successful American landers and rovers, and Perseverance is joining the party. For me, when I try to remember where stuff is on Mars, I take a kind of Earth-centric approach. So Perseverance is somewhere, if this is a projection in which Europe is in the middle that I grew up with, Perseverance is landing somewhere in southern Russia, the Stan countries, and Insight, Curiosity are in Southeast Asia, Spirit's in the middle of the Pacific Ocean, Phoenix is in the Canadian Arctic.
Very fitting.
Yes, it is very fitting. But this is where Perseverance is going on a global scale. And we'll talk all about where exactly, but the crux of it is this Jezreel Crater, which is a crater in that, as you saw, eastern hemisphere of Mars. And something to pay attention to is this river-like feature that has burst through this crater's walls, and craters often have rims like this around them. And this is going to be important into why we're going here and what Perseverance will be looking for. But a neat thing about this is what is called a landing ellipse. I think we've talked about them before, but they've gotten increasingly better. And Phil, you can remember, obviously these landing ellipses are for different places on Mars, but they're put here for comparison's sake.
Yeah, to show the size, yeah.
Yeah, so there's a number of reasons for this that include everything from algorithms run while the spacecraft is on its way to Mars to what we'll see later, radar imagery that can look at the surface as the spacecraft is approaching the ground. So Phil, I guess in some ways your job of mapping landing ellipses is getting easier or harder?
Yeah, that's right. It's certainly covering a lot less area. I might point out that the Perseverance landing ellipse shown there, the one right there, that's about the same size as the Apollo landing ellipses on the moon were.
Oh, cool.
Yeah.
And you'll notice Viking's not even on here because it's so big. It wouldn't fit in this view.
The planet. Hit the planet.
Somewhere in the northern hemisphere.
Yeah. So increasingly, these landing ellipses, these targets where you want to touch down, have gotten smaller. And Phil, I mean, when you have humans on board who can make split-second decisions, as they had to on Apollo, which you can read all about in For All Humankind, they were able to hit pinpoint landings, especially Apollo 12 onwards.
I guess I have a question. Maybe Phil, you might know the answer to this. Yeah. So, like, looking at even the size of the Curiosity landing ellipse, pretending that we were landing Curiosity in Jezreel, we certainly wouldn't have been able to pick that ellipse because of how much of the delta takes that up.
No.
Do you think we
in, wouldn't you?
Yeah, I was going to say, do
Right,
you think
so
we would have even tried to land in the crater if we were still using a Curiosity landing ellipse?
um, well, I think the short answer is no, that people wouldn't have tried to land there because it's a much rougher site. And the thing that has made it possible, apart from increasing accuracy like that, is this wonderful new tool called terrain relative navigation, which basically allows them to go to a safe, smooth spot much more precisely than before. Without that, you're going to land somewhere in the ellipse and you're not quite sure where. More likely near the middle, but still you're not really sure where you're going. But with the procedures that they're using, they were able to find out exactly where they were on the way down and get themselves to a safe place. So that's what is making this possible.
So, I think both of you at least were following, if not directly involved in some of the workshops to decide where to land this thing.
I was part of the workshops for that.
Yeah, so you would be familiar, maybe not with this artist rendition, not a real image from Mars, but a lot of craters on Mars at one time, we suspect, were filled with water. Water is necessary for life, so far as we know right now. And when this dried up, all the water left stuff behind. And now it definitely left stuff behind, like sediment and whatnot. And that sediment's made out of may vary. But it may also have left behind signals of any life that may have been in that water. So, Tanya, what do you remember about why they chose Jezreel Crater? There's other craters that were covered in water. What was special about this one?
So there were not only other craters covered in water, but the main thing that drove us toward Jezreel was the delta that's in here. And if you remember back to Curiosity, maybe folks don't remember, but one of the top 2 candidate landing sites for Curiosity was another crater with a delta called Eberswald. And deltas are really significant because it tells you that you had some flowing water like a river that has emptied into a standing body of water like a lake or a gulf or a bay. And when that water has been moving quickly and then stops, everything that's in it kind of settles down to the bottom and forms these layers. A really good example of this is if you go into Google Maps and look up the southern part of the state of Louisiana, that's basically all the delta of the Mississippi River emptying into the Gulf of Mexico. And it's very distinctive looking. It's really good at trapping biosignatures or biomarkers within it, because if you had any type of like microbial life or plants or fish, probably not fish on Mars, but you get the idea, it might get trapped inside those layers that are building up. So not only do we know that there was a river flowing in to form this delta, but you'll notice in this artist rendering, there's another river going out the other side of the crater, which means that this crater was filled up with water over time to the point that it overflowed and flowed out the other side. So it tells us that the water was there for a while. That's really key. And we'll see, I don't think you have the mineralogy slide for a few more slides, but the mineralogy of this crater, and specifically the delta, was a lot more interesting than what we saw at Eberswald. And that's because we had more instrumentation in orbit, thanks to the Mars Reconnaissance Orbiter, to help us map out more of the planet with new hyperspectral imagers to find a better landing site than what we knew with the data that we had when we put Eberswald at the top for Curiosity. So that was one of the big reasons for choosing Jezreel over the other candidate landing sites that we had.
Yeah, we'll see that the alluvial fan, the delta, in other images of Jezreel Crater, where you see essentially this river breaks through the rim and then it just goes, it spreads out all of its stuff. And if stuff was living, it'll, as Tanya said, will be trapped in there. So back to the nasty business of actually getting there. You can see all sorts of videos about this right now. This is another artist's rendering, but this is the spacecraft in its protective shell entering the Martian atmosphere. Thankfully, Mars has about 1% of our atmosphere, even less at the surface, but enough to slow things down, which is good for getting there, bad for getting off. We may talk about that at the very end. So we have the spacecraft coming in at an angle. Always important to remember most spacecraft landing are not just coming down like a spaceship. They are coming across the terrain, slowly lowering. And this is what Perseverance, wow, is doing. So to slow it down again, thankfully having an atmosphere means you can use a parachute. There were no parachutes on the Apollo missions because parachutes are useless on the moon. This is slowing it down considerably. And this is a real image that we got today. And this is from NASA. And this is from, I'm just going to go back to the artist. Sorry, Tanya. Artist rendering. In the past, and this was explained really nicely on the press conference today, in the past, there were no cameras on during all of this. And certainly there were cameras this time. They weren't live. Maybe that's what will happen next time. But there were cameras looking up. There were cameras looking, well, down in a second. The heat shield's in the way. So this one's looking up, obviously, at the parachute. This was revealed today. Really cool image. Phil, what did you think? I don't know if you got to watch the press conference live. But
oh, I did, yeah.
I think any planetary person had nothing else today other than making sure they watched that press conference.
That's right.
Yeah.
Hold my calls. Yeah, that's right. yeah. So, it was great to see it. It's quite amazing to see all this. And what about that very complicated red and white pattern on the parachute? Apparently, there's some information coded into that. And one part of it is the initials JPL coded in a certain way in there. But we'll probably learn a bit more about that later on.
Yeah, I didn't know about that. Well, they had taken a code somehow because they lost the wheels.
Yeah, right.
So this is also a real image, 2 real images. But this is one of our trusty satellites going about the planet, going around it, Mars Reconnaissance Orbiter, capturing Perseverance, descending by parachute. So this is quite the amazing picture. This was from the first batch, I think, on Friday. Yeah, because this was on Twitter all weekend. So this was really cool. I don't remember if this was planned or not, or if they knew they would be able to capture this.
Well, they definitely
planned it. It takes the most exquisite planning to make something like that work. But I should point out that this is the 3rd time this has been done, because we also got images of Phoenix and Curiosity coming down to the surface on their parachutes. It wasn't.
That's just mind-blowing. Like, you have both spacecraft are moving. You have to slew MRO at a crazy angle to be able to get it looking like this, and you hope that the timing is right.
Yeah.
And it. You know, they keep saying each time they try to do it, they're like, "Oh, it's almost a crapshoot. We don't know if we'll get it," and then they manage to get it like every time they've tried, which is really impressive.
Yeah, it is. Yeah,
and that's I always feel like I never hear about it beforehand. And maybe that's because they don't want to go, "Oh yeah, we'll definitely have orbital images of the parachute." But is the parachute and lander that reflective in the inset here, or is this contrast enhanced? So it looks nice and bright.
Well, I'm not sure about the processing. The inset certainly looks darker than the background image, though. I mean, it's really the same image, but it's just a blow up of a little bit of it. I would imagine that actually what we're seeing in the background image is pretty much the contrast you would see if you were there, and they've really cranked up the contrast in the inset to show the details better.
So bright. So this is a real image. So as it's descending with the parachute, it eventually gets rid of that heat shield that we saw on the bottom, protecting it as it enters the atmosphere. And this was an image that was released today of the heat shield separating. And this is where we're going to get into some Apollo nostalgia, because this is reminiscent of a few kind of heat separation images that we've seen in the past, whether at the moon with the descent stage separating, segments of the Saturn V separating. So this is cool to see at Mars with a brand new system.
It's also very similar to the descent image that we got of the heat shield separating from Curiosity from the Mars descent imagery.
Yeah, that's right. That's right.
So back to artist's rendition. This leaves the rover in this shape. And what this allows is for a radar to start scanning the surface. And this is what the radar sees. and this is part of what Phil was talking about to help, if I'm not mistaken, to help it land in not only its proper ellipse, but also avoid any scary jagged rocks, right?
Right. Well, that wouldn't be radar data though. That's somebody using GIS to map out hazardous areas. Lots of rocks, lots of rough surfaces, steep slopes. So it's a hazard map, and it's showing in blue the areas that are safe to land. That radar is really for just getting the height off the surface, I think.
Okay. Interesting. This was initially on the Perseverance page and then was removed, and I couldn't find much about it.
Okay.
This is what we saw today. This is
like this is a crater.
no.
On the right-hand edge, you've just got a little tiny bit of the delta just poking in there.
Oh, interesting.
Yeah, and like some nice dune features like collected along the rim there.
Yeah, so this is the spacecraft descending by parachute, just with its camera on, which I thought in the video we'll see was really, really cool. Back to artist rendition. So they eventually get rid of the parachute, get rid of the descent stage stuff, and go to this powered descent with retro rockets firing in the reverse direction of the fall to slow it down. And we get the sky crane maneuver. So these are the real images that were released today of the spacecraft, of the rover, descending by tether, cord, cable, rope, whatever you want to call it, down to the surface. On the right side there, you see the image of the dust being kicked around, which is nice. We can actually see in later images the actual pattern of the dust being kicked back from where the rover is. So this was really exciting to see. And this is, I guess, what people were hoping for. And today's press conference didn't disappoint. This was one of the images released before the weekend, a high definition capture of the sky crane lowering the spacecraft onto the surface. Yeah. You get this artist rendition of the spacecraft on the ground from the sky crane. And seconds after this, that top part would fly away and crash into the ground. Once you have touchdown like that, you have very happy, yes, that is a real image. At JPL, I'm very happy planetary scientists. Where were you two watching?
Oh, I was just in this room watching everything.
Yeah. I was home, but co-hosting the We Martians live stream with Jake Robbins.
Oh, great.
So as a quick recap, that's everything that happened with this descent. And I'll play this video. We can talk over what's going on. But this was the video that was really kind of the big reveal of the press conference today. And yeah, the cameras caught a lot of the key moments of entry, descent, and landing. And we've never seen this stuff before. So, Phil, I don't know what your thoughts are.
Well, yeah, it is quite amazing to see it. These are two cameras. There were three cameras looking up at the parachutes, and one of them failed, but the other two worked. I suppose they were just there for redundancy, really. But yeah, quite something to see that. Every other camera in the EDL system worked.
I'm impressed too, like especially this early part of the descent sequence, how similar it looks to that interpolated version of the Marty sequence from Curiosity. Like the original images are not very high resolution, but somebody on YouTube managed to take it and make an interpolated version that's like HD quality. And it looks just like this. Like the technology we have just for image processing is incredible now.
Yeah. That's right.
But of course, this is a little bit cooler only because you can see the delta, like the fact that we can see it coming down.
Yeah, it is.
Just tying it all together with the orbital imagery is so cool.
Tanya, do you think? Do you think these images from this kind of float down have scientific value? Do you think people will dig into these for papers and stuff?
Oh, absolutely. I mean, you're getting higher resolution views than we get from orbit. And I think especially as we get closer to the surface and you start to see stuff like the dust kicking up, since we have the velocity measurements and the altitude measurements from the rover as it's coming down, I could totally see some dust dynamics papers coming out of that.
Yeah. Mm-hmm.
And it's kind of a weird, unique, like, it's such an earthly kind of camera angle. Like, it's very clearly just looks like someone on a balloon or like an iPhone on one of those balloons. We've never really had this from another planet. I found it really strange today to watch. Like, it just seems so different visually than all the other footage we have of the solar system.
Yeah.
And now here you can tell you're not on the parachute anymore because it's so much more stable. I like that they included the little handy guide at the bottom too.
Oh yeah, that's right. Yeah. Yeah. And this is where they're diverting to the safe spot after the cameras have figured out where they are.
Yeah, beautiful, like, visual example of the terrain relative navigation. And then here comes the dust. Oh, that part is so cool.
Yeah.
And we have that from Curiosity, but it's not nearly this high def, and we certainly don't have the views like from the rover looking up. Like, seeing the sky crane in action, that's so cool. Like, we couldn't fully test that on Earth because of the gravity and and the atmospheric conditions. So just actually getting to see it work, and then they're just flying off.
Yeah.
Bye.
Yeah, that was really Apollo 17 kind of, whoops. Just that ascent footage is also something we don't get a lot. Like, how many ascent footages totally do we have other than the Apollo mission?
That's a good point, yeah.
But yeah, this here is really cool. Whoop. And then, yeah, I mean, obviously very, very happy people. But not just JPLers were happy. Everyone in the planetary science community was very happy about that. And
real image.
There she
a
is.
real image. And so, Phil, am I correct in interpreting these bright spots are remnants of the kind of dust kicking around?
Well, there are places where the thrusters, which are angled out a bit from the rover to protect it, where the thrusters impinge on the ground with the greatest force, and they really scour the dust away from that spot. Yeah.
So again, this is where Perseverance is. It joins the family of everything that is successfully landed, along with Mars 3. And here it is in a broader context. I think this is from today. And again, this kind of crater wall that we'll be talking so much about throughout the entire span of this mission. A little bit of space archaeology here. Phil, you dig around to find these. They got it pretty quick on you. But
yeah, that's right.
Yeah, Perseverance is down here. Yeah. The thing that flew away, the ascent stage, well, not an ascent stage, the descent stage, that ascended away, crash landed here. The parachute and the back shell is there, and the heat shield is here. So I was very pleased with this image being released, because I like these kinds of things, and it shows also how far away. Most of these are about between half a kilometer, the descent stage, to about a kilometer and a half away from Perseverance. So they do a good job keeping Perseverance safe from these things.
Because the descent stage and the parachute are kind of in the direction of the delta. I wonder if we're going to drive close enough by them that we could like snap a photo on the way.
Yeah, it might be possible. Yeah, they still haven't figured out exactly how they're going to get from here to where they want to go. Yeah. There we go.
So this is what Tanya was talking about earlier, and one of the big reasons we chose Jezreel. So again, this is kind of that on Earth we say alluvial fan. I don't know. You guys use that on Mars?
No, I mean we would call this a delta. Alluvial fan is different.
Okay. so this delta being released from the river into Jezreel Crater. Perseverance is not visible here, but these colors represent geochemical information. Tanya, I don't know if you have more on this image.
Yeah, I'm bummed that this image gets shared a lot, even by NASA, with no labels on it whatsoever, because I don't want people to think that Mars is psychedelic colors. But these colors are telling us the mineralogy of the delta. And one of the cool things here is that, if I recall correctly, the blue area are all of the carbonates. And for the longest time, there was a mystery of the missing carbonates on Mars. We know that the atmosphere is predominantly carbon dioxide. We were predicting that we should see carbonates all over the place, and we weren't finding them with hyperspectral imagers from orbit until relatively recently in Mars exploration history. And now we're finding them in bits and pieces here and there, including in Jezreel, but they're still not as widespread as we would expect. So one of the questions that's come up a lot is why? Like, why don't we see them everywhere? There's also a lot of clay material in this delta, which is really good on Earth at preserving biosignatures. And there is often water in the chemical structure of these clays. And so it's a good place for us to go and learn about the history of water on Mars.
Yes, and one other thing that we might say is that although a lot of attention is focused on the delta and the clays and the possibility for a sort of habitable environment and so on, there are other things that Perseverance will be looking for. And one of them is more towards the right-hand side of this, where you get more into the sort of gray to slightly purplish colors that are smooth, the smooth surface to the right of the delta. One interpretation of that is that it could be volcanic flows, lava flows on the surface, and they really want to get a sample of volcanic material if they can, because they can get a good date from that to figure out when those lavas erupted, and they would really like to do that. It's not absolutely certain that those things are lava flows, but that's one of the possible explanations for it anyway.
Yeah, we definitely got tricked in Gale Crater with some dark-toned, heavily cratered units that we were pretty sure from orbit were lava flows because they seem to be dark and resistant to erosion. Got there and find out they're just really weird, hard muds. So this could throw us a curveball. But it makes sense. We are, in a volcanic province. Syrtis Major is, just to the west of this crater in the grand scheme of Mars. So it'll be interesting to see what the floor is actually made of.
Yeah, and one important goal is that if you have a surface like that you can count craters on to get an age estimate, and you can get a radiometric date for it, then you can calibrate your crater counting, and that's really important for Mars. And this is one of the things that they would like to do if it's possible.
Just looking at the number of kind of, I don't know if they qualify as fresh, but more recent craters, even one on top, which is, interesting.
Well, that gets tricky on Mars because there's fresh surfaces and then there's recently exposed surfaces. You could have units that have been entirely buried, but that are ancient, but they've been exhumed geologically recently, and so they don't actually have a lot of craters on them. What these units can tell you more is, since the dark unit that we think is a potential lava flow is full of small craters, those are craters that you would expect to erode away more quickly than larger craters. And so something that has a lot of small craters preserved on it is either probably very young, very recently exposed, or very resistant to erosion. But it could be resistant to erosion, but still old. It just hasn't eroded away just because of the mechanical properties of that rock, if that makes sense.
Yeah. So again, just a reminder that a lot of this expected geochemistry comes from the ancient history of Mars, probably wet, and then as Phil was talking about, volcanic activity that may have influenced this area as well. So we'll find out during the mission how exactly that goes. So this image is one of the earlier, and I'm not sure if this is still the plan, Phil, you would know, one of the earlier traverse maps to kind of work its way up the delta towards the rim of the crater. Phil, what do you know about the latest on kind of the planned traverse?
Well, right. So this is sort of approximately what they're thinking, and towards the end of it, the upper left, you can see it heading out into the highlands, and there's another what was considered a potential landing area, a few. Quite a few kilometers further out in that direction. It was called Midway. And what they're going to try to do, in fact, is to collect samples here and then drive to Midway and get samples along the way. And they can expand the range of things that they can sample that way. But they're not necessarily going to follow exactly that path, but some kind of path, something like that is probably what they will do. And they've identified a bunch of places that they really want to get in and examine. But then you start to run into the question of what you're going to do with those samples. And the whole point about these samples is that they're going to be carefully stored and deposited on the surface and then picked up by a future mission and brought back to Earth. So where are you going to leave them? And they had there was a sample caching workshop in January, which discussed this in a great deal of detail. And they outlined a plan that was kind of similar like to that. But what they're going to do is, as they drive along, they're going to collect all of these really important samples. They'll get samples of the crater floor, different parts of the delta. They'll get into the carbonate materials and sample that, clays in other areas, all these kinds of things. Then they're going to get up to that crater rim that we can see in the background there. And they want to get a sample of the crater rim as well, because that's going to give us a date for the crater itself. So now you've got a really nice set of samples. And at that point, they want to set out a cache with those samples in it that could be picked up by the future spacecraft. But then they're going to drive on and pick up more stuff along the way. And then they would make a cache of that. But only one cache can be returned. So how do you maximize the benefit of what you're doing? Well, what they have to do actually is they're going to collect those samples here in the delta and on the crater floor and at the crater rim. But they're going to take 2 of every one of those samples. And when they get to the crater rim and they're in a nice safe place where the sample return mission could land, they're going to leave one set of those samples. But they're going to keep a duplicate set on board. And as they drive through to Midway, they can collect additional samples. And then they'll make a second cache, which has everything in it at the end. The reason that they want to cache something in here first and then go on and do the other part of it is that you never know if the rover is going to break down. You could have a catastrophic failure of some important system in the rover. You can't drive anymore. You're stuck in an awkward place where they can't land to retrieve the sample, something like that. Anything could go wrong. So you have to protect yourself against that. So you get a nice set of samples here and you leave them near the crater rim. And then you take your duplicate set and collect some more samples, and then you make a second cache further along. And most likely it's that second cache that would be picked up because it's more complete. But in the event that the rover failed and wasn't able to deliver samples, you've already got that other cache. So it's a kind of insurance policy.
Yeah, it's essentially a save point that if the mission doesn't make it all the way, there's a halfway point with certainly some good samples, some of the more important samples, arguably, that is available, and then everything else is gravy. So yeah, and Phil, you bring up a good point. The whole point of this mission, or a huge part of it, is the notion that it's going to collect samples, store them on board for a little while, and then not hide them, but put them down somewhere on Mars for another future mission to come grab them. That remains to be worked out, but NASA and the European Space Agency are working on it. So yeah, this traverse map, like Phil says, things will always come up and things will change here and there, but this is the general plan.
Mm-hmm.
Artist rendition, Curiosity. This is before the landings. Curiosity, wow. In Jezreel Crater with the crater rim behind it. and some driving to do. So this is one perspective of what it would be like to be on the surface right now. And let's get to then, I think not all, but most of the images from here on out are real. And this was the first image the rover itself returned from the surface. Not the greatest image in the world, but it's the first one. And Phil, you mentioned there's a reason this isn't the greatest image.
Well, first of all, it's very downsampled. It's a very small version of the image, but it's also, you see this circular outline, it's being photographed through a protective cover. So when the thing lands, there's all this dust flying around everywhere, and you don't want to get it on your cameras. So the cameras are all protected behind covers, which have a circular outline, and the initial pictures look like that. But then you pop that cover off, and now you're getting much better quality pictures. So the later ones are obviously much better looking than that, but they're also rectangles instead of circles.
And let's step back a bit and answer Cass's question. Maybe Tanya, you can, maybe the correct image for that is this.
Yeah, this is a good one. So this is another big mystery of Mars. How has so much stuff eroded away, and where did it go? There are entire provinces of Mars that appear to have been buried and exhumed. Most of Arabia Terra is one of those regions. Another region, Gale Crater. All of Gale Crater was filled and buried and then exhumed at some point. And we can tell this because Mount Sharp in Gale Crater is taller than the crater rim. And there's no way that you could have built up those sediments unless at some point the entire crater and the area around it was filled up to some level, and then it eroded to what we see today. Mm-hmm. And, Cass says she's doubtful wind would be enough. That's probably actually what it was. If you have the only thing that's acting on the surface is wind for millions and millions of years, it might be extremely effective on Mars. We obviously have some places where you have water erosion, water most likely carved this channel that we're looking at here. But wind erosion appears to have been highly effective on Mars. And because we have so many other factors on Earth that influence erosion, I think it's hard for us to fully understand the power of wind, because even in places that are dominated by wind erosion today, like hyper-arid deserts, they haven't all been hyper-arid deserts for all that long in the geologic sense. The Sahara Desert used to be essentially a rainforest not that long ago. The Atacama Desert hasn't been a hyper-arid desert forever. The Antarctic dry valleys in the geologic sense haven't been a desert for all that long, compared to how long Mars has been bone dry and had nothing acting on it but wind.
Yeah, I think that's a really good point. It's easy to forget that our world is so dynamic and it's always changing. So sometimes it's going to be dry and windy, and other times it's not. But Mars has been dry and windy, for 3.5 billion years at least, maybe 4. Just So
yeah. And there's another. There's another good question there about the impactor for the crater, and let's get an image of the crater. And I'm sure either can handle this, but the thing that the asteroid or comet, the impactor that created this crater, what happened to it?
Well, it's completely destroyed by the impact. The impactor is much smaller than the crater, and it's gone completely, and everything around it is gone. It's not sitting there inside the crater. It's been vaporized and blown out, and it's mixed in with all the ejecta and stuff that was thrown out of the crater. But you're not going to find a big chunk of meteorite sitting inside the crater that was left over from that impact.
All right, so let's get to some of the nicer images. This was the first color image released from one of the belly cams of the rover. And these are going to be looking at what's, of course, underneath the rover. Anything of note on this one? Obviously, we can see the wheels. We'll talk about the wheels in a sec.
So on the horizon to the right, you can see some distant hills, and that's part of the rim of the Jezreel Crater.
So that's the route of that's the direction of travel.
No. The picture looking in the other direction shows the way that we'll be traveling. But that's part of it's another part of the rim of the crater.
These are the wheels for those of us who followed other rover missions. Curiosity, the rover that landed in 2012 before this, had some very unique wheels. One of them because JPL was spelt out in Morse code or in some sort of cipher. I don't remember if it was Morse specifically.
Yeah.
These wheels are different. They do not have any sort of code on them, and they're also, well, we've been told much stronger and more resistant to some of the sharp rocks. This image also over the weekend, because it was one of the few great images out, got a lot of attention for those holy rocks. I don't know if either of you have much in either the wheels or the holy rocks.
Well, I've seen a lot of discussion about these rocks, and people tend to either think that the holes are places where there were little crystals or perhaps other kinds of chunks inside the rock that have been eroded out. And if so, that's what we would call a vug, a hole where something has been eroded out of it. The other possibility is that it's a piece of lava, and that the holes are where there used to be bubbles in the lava, which were kind of locked into it when it solidified. And now erosion has kind of opened up some of those holes.
Excellent. Let's move on. I didn't. This is one of the images released today, high resolution color image of the rear end of the rover. And you can see there one of the color scale palettes that's used to help with colorization of the images. And the word is escaping me. But
Calibration target.
Calibration, that's the word. Thank you. So all of these images come, you can see in the raw data on the website, they come in various hues, mostly the same kind of grayish, bluish color right now. And then people correct the colors on them to what our eyes should see. This is one of a pair of images of the rover itself. Phil, was there anything that stuck out about these two?
Yeah, well, one thing I was going to say about this was that when it lands, there's dust and stuff flying all over the place. But this top of the deck, the top of the rover there, what they call the deck, is amazingly clean. You'd think that it would have picked up a lot more dust during the landing.
Do you think it was a couple of lucky nights or mornings, more likely, of wind?
No, I don't think so. No. The deck is a very complicated shaped surface. So if debris got on top of it, it would be trapped in all sorts of little places on there. And it just looks very clean.
This image caught some traction on Twitter for this little family montage here of the previous rovers on Mars. So Opportunity, Spirit, Curiosity, and now Perseverance.
And Sojourner.
This is I don't know if that was known about ahead of time. I
didn't know about it.
I don't think I knew about it either, but it's very, very cute.
Phil, this is one of your projections of what the rover right now would see in front of it and behind it.
Right. So these were from the two hazard camera views that we had quite early on. Nice color hazard camera views looking out in two opposite directions. Looking down to the lower right, that's the forward end of the rover. And towards the upper left is the back end of the rover. So you can see which way it's facing. In that view towards the back, the upper left, you can see the edge of the delta as a range of sort of nearby hills, and then beyond that, much bigger hills. And I have to say that the height is greatly exaggerated in the way that these images are projected. So the hills are not that high and they're not that jagged, but the way that this is projected, it makes them look like that.
And this was a release from today, one of the NASA JPL's own panorama of what the rover can see on the horizon.
This is amazing because these are from the navigation cameras. And usually we only get images that look like this on previous missions from the actual like color eyes of the rover, like science cameras. But the science cameras haven't been deployed yet because we still need to deploy the mast. But all of the nav cams, like on previous missions, they have just been grayscale. On Curiosity, they're like 1024 by 1024 pixels. These are 22 megapixel color cameras. So every single nav cam image that we get back is just going to be stunning.
Yeah.
And to add to this, the team released some audio, and I've got it here. It's not overly loud, but they released two versions. One of them has the sounds of the rover itself, and the other one is just the Martian atmosphere. The Martian atmosphere is very, very quiet, so you may or may not hear a small little hiss. But if you listen to the second one, this is the sound of the rover and the nearby environment. So there's the microphone is picking up. Whoops! Whoa! The microphone is picking up the electronics and stuff like that. But
I'm not sure the sound is coming through the stream. I can't hear anything.
I couldn't really hear it.
Can you hear that?
No. I mean, I've heard the original audio file and it is quite quiet. So maybe it just doesn't come through the stream very well.
Okay.
Right. So this is actually from the navigation camera panorama that we just saw. And here it's just been wrapped around into a circle. And again, it somewhat exaggerates the height of distant hills, although not as much as before. But it's so that the image is kind of laid out in map form and you can see what it looks like around the rover. The rover's right at the center with one of its, well, the low gain antenna is the thing. It's up to the upper left there.
Our monthly fill connection issues.
Always right at the end. That's so strange.
Oh,
Yeah.
okay. Oh,
It's like
all
the
right now?
internet runs out of steam.
I
Yeah.
can hear you now. Yeah.
Deep
Okay.
Space Network will brought you back.
Okay. Yeah, so that just gives us an idea of what the site is like around the rover. Ah, great.
So now that we're safely on the ground, we know where we are. It is time eventually to get to work. There's a few more stages to carry out, as Tanya was mentioning, unfurling the mast and all that. But there's 7 main instruments on board this thing. We won't talk about them all. But there's some unique ones. This one particularly is new, MOXIE. So it's going to experiment with whether or not we can, not synthesize isn't the right word, but extract oxygen from the Martian atmosphere at a very small scale. And I know there was a question earlier about the MOXIE. And I mean, I'm no expert, but I would say hypothetically in the distant future, maybe. But the question would be how much oxygen is there period on Mars to extract? To terraform Mars, and some answers are certainly not enough. But MOXIE in the short term is certainly more about exploring to what extent could we extract small amounts of oxygen, whether it be for astronauts or greenhouses or anything like that, in the next decades, probably the 2040, 50, 60, something like that. Sherlock and Pixel are neat. Any instruments stick out for the two of you?
I would mention RIMFAX, the radar, which will penetrate down into the ground and look for buried ice or just layers of rock, just to give us an idea of what's below the surface. Never tried before on Mars, but although it has been done on the Moon.
And quite often on Earth.
And lots of times on Earth, yes. That's
ground
true.
penetrating radar. So
We don't talk about Earth.
That's for another channel.
So just another artist rendition of one of the ARM pixel at work. Sorry, and so we'll leave with just a couple animations to talk over. Yeah, one of the big things that this mission is going to be doing is collecting those samples that we were already talking about. And Phil, I know you were talking about the sample collection and caching workshop.
Mm.
Where are they right now with kind of deciding where samples will be taken when? They haven't grabbed a contingency sample right away, Neil Armstrong style. So what are the plans for when the first sample might be taken?
Well, first I'm going to say that they're not going to take a contingency sample right here because this area is contaminated by exhaust from the landing. So they don't want to sample this. No, they'll go off some distance before they do that. But they have a map laid out with lots of potential sampling sites. Exactly which ones they use will depend on what they actually see on the ground. Because everything has been planned from orbital images, and they might see something different on the ground. They know the kinds of places they want to sample, and will go and look at them and collect the samples in the appropriate places.
I like the part of the animation where it like takes the sample and then kind of looks like it's putting it in its pocket like a pen. Yeah. Like, I'm just going to stick this here.
Yeah, I mean, the sample collection process is just from analog missions. It's, you only get so many. So is this one worth it? Are you sure you're not going to find something better? And I mean, often there's we're not going to be in a location like this again. So that makes a lot of sense. But if you don't know, or if it may mean a few extra hours of time or energy from the rover, then there's some trade-offs to be made about where you choose samples from and what they'll be representative of.
Mm-hmm. All right.
Sample tubes is there's a CT scan of them on Perseverance's site. Thought I would include them.
Yeah.
And last and least is Ingenuity.
Do you not love the helicopter?
No, I don't dislike the helicopter. It's neat. It's cool. So, Tanya, what do you have to say about the Ingenuity?
So Ingenuity is a technology demonstration, which means it doesn't have any science goals of its own. It's really just designed to see if we can fly in the Martian atmosphere, which has never been done before. It's never been done on any planet beyond Earth, actually. So this will be really interesting to see. They've tested it in a simulated Mars chamber at JPL, and it works. The original goal for this was to be a full-fledged instrument that would fly ahead of the rover and take images along, notional traverse paths, so that we could make quicker decisions about where the rover should drive. Because right now, it's all based off of a series of high-resolution images from satellites, like taking images from HiRISE, which is good. But even at 25 centimeters per pixel, it's not good enough to do super fine scale planning. It can't see the smaller hazards on the surface. So right now, the way we've done it with previous missions is the rover has to drive, and then it will stop, and it will usually take like a 360-degree panorama, or at least a drive direction panorama, and then somebody will look at that and try to figure out, okay, there's rocks here, here, here. We want to go to this point. Let's go around this way. But ideally, we have technology now, thanks to things like automated driving on Earth, where you could theoretically ingest images from a drone like this, send them to the rover, and say, the rover is point A. I want to go to point B. I don't care how you get from point A to point B, as long as you take the safest route to get there. So that would have been great. Unfortunately, the helicopter, like the full-fledged version, got descoped. Actually, the whole helicopter was descoped at one point. And then eventually it got added back on as this technology demonstration at a significantly lower cost, but also significantly lower capability. It will still be very cool, though, to see if something will fly on Mars. And I can't wait to see like pictures or video from the rover of the drone, hanging out in the air nearby.
Mm.
Yeah, and it's neat that the Ingenuity's function is entirely based on the rover, so it communicates with the rover, and the rover communicates with us on Earth, not me specifically. But it's neat, and I don't dislike the thing. I think it's really, really cool, and it'll be awesome to fly on Mars. I'm just scared for the rover's sake. This thing has to fall off the bottom of it, 2 legs at a time. It's being hatched like a baby.
Gee, this sounds like you've been heavily influenced by conversations with one of our friends.
No.
Okay, here's Matt asking a smart alecky question. No, we're not going to shoot the Ingenuity down with the laser, Matt.
But I mean, after it's successfully flown and you've tested the technology, why not try to shoot it with SuperCam? I'm okay with this plan. SuperCam
I've
team
always
members
wanted
maybe not.
BattleBots on Mars. Could be the closest. We've never had two robots close to one another, so this would be the first time you could actually have a robo fight. So yeah, I mean, Ingenuity. It's right now. It's sitting on the bottom of Perseverance, in between its two belly cams. And today they said that everything looks fine with it. Looks like it survived the landing, and everything looks all great. So when the time comes, they'll lay the egg, and they'll drive away 100 meters away, and the thing will take off. I think we were talking about this as well, whether or not the mass cam will be able to follow it or catch it. I don't know the answer to that specifically. I can't remember what we kind of figured, but I mean, maybe they'll snap a picture of it in the air. I imagine that's a possibility.
I'm sure they will, yeah.
Yeah, it won't be able to pan fast enough to be able to track it as it's moving. But if you know the direction that it's flying in, like away from the rover, you could set it on the wide angle zoom end of the camera and just kind of shoot in that general direction, either video or photos, and see if you catch it that way. Kind of like high-rise style. Let's slew the spacecraft and point in the direction of where we know Perseverance is landing and hope we catch it in the frame. It'd be the same kind of thing with the mass cams trying to catch Ingenuity.
Yeah. And one other thing to say about it, right now it's suspended underneath the rover, and that doesn't leave very much ground clearance. So actually they can't drive long distances and do all their sampling and everything with Ingenuity still there. They have to, sometime in the next month or so, 30 to 60 days from now, they're going to put it down and do the tests with it and everything. And then they can go off and do the sampling. But they have to actually ditch it before they can do very much.
There's actually a funny question in the chat, but it's actually a good question. Will the rovers sing happy birthday to each other? So the instrument on Curiosity that's saying happy birthday to itself is actually not on Perseverance. So it doesn't have the ability to do it, or at least not in the same way that Curiosity did. That was the SAM instrument on Curiosity.
We do have a couple other questions. One of them was about the wavelengths of some of the cameras. I can actually go back, but I don't know if either of you wanted to quickly tackle that one.
I worked on Mastcam Z, so I should know the filter wavelengths, but it's been a while, so I don't actually remember.
And the other question, so sorry, we don't off the top of our heads have the wavelengths available, but those are certainly easy to find. Any chance we'll find caves on the journey? So there are subsurface features on Mars, but I'll take a quick stab and say I don't think there are any around here, but I could be wrong. Phil?
I'm not aware of anything in this area, no. Normally you need a really big volcanic region for that, and then where lava is crusted over and continue to flow under a crust, it can sort of vacate an area, and then you can get caves forming like that, lava tubes. There aren't any in this area, but I suppose it's conceivable that there could be some other kind of cave, but I don't think anything is known like that now.
Yeah, you could get like some, well, I mean, if there was water, karst-like features are possible, but I've been wrong on like 3 different geology things today, so I'm just going to shut up.
It's okay, you're a geographer, we'll forgive you.
That's right. Okay, so thank you everyone for joining. Any final words? Tanya, what are you most looking forward to in the next month?
In the next month, successful deployment of the mast and see the first Mastcam images. I'm biased, but yeah, I'm excited for those.
Yeah, they will be exciting because those cameras are going to be absolutely amazing. And looking at things like the distant hills and the crater rim in Mastcam images will be fantastic. Yeah.
Awesome. Well, it's been a really, really interesting week. We only get one of these every decade, roughly, unfortunately, although we'll be getting quite a few more coming years. but this was the first one in a long time. And for me, it's certainly the peak of space exploration. So thank you everyone for joining. Thank you everyone for asking questions. And we'll see you in a month with another update. I'm sure we'll talk about Perseverance, and we'll dig into some other mission of the past or present.
Great.
Yeah. And remember, if you have any suggestions about topics you would like to see us cover in these historical deep dives, let us know on Twitter or YouTube or Facebook in the comments of any of these videos, because we do take a look at them.
Awesome. So follow along with Perseverance Online. Follow Tanya on Twitter. Follow Phil on Unmanned Spaceflight. If you want to see all the latest maps and images, you can follow me on Twitter as well. So thank you, everyone, and we'll see you next month.
Okay. Bye.
Bye.